Hello, Algebra 1 students. So this is going to be 10.8 part 1 or day 1. Okay, this is going to be split up into 2 different days. So I have 2 separate note videos for that. And this is going to be on factoring, which is what we've been doing, but we're going to be using a different strategy where we're going to find the greatest common factor. So what is the greatest common factor? Let's talk about that a little bit. All right, let's try to find the greatest common factor of 24 and 40. So the first step, probably guess, is finding the factors of each of these numbers. So again, factors are just 2 numbers that multiply together to get the number you're trying to get. So like factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's all we have for that one. Okay, so factors of 40 include 1 and 40, 2 and 20, 3 doesn't go into it, but we have 4 and 10, okay, 5, we have 5 and 8. Okay, so when we're looking for the greatest common factor, we're trying to find the largest factor that they both have in common. All right, well, they both have 1 in common, okay, but that's the smallest. They have 2, okay, but we can see that the biggest one they have in common is 8, okay? So be careful, we're trying to find the greatest common factor. So what is the greatest common factor? Okay, that they have the same. They have the same, so 8's in both of them, so the greatest common factor is 8. Another way to think is like, what is the greatest common factor? They have the same as what is the largest number you can divide all the numbers by. So what's the largest number you can divide all the numbers by? So the largest number that we can divide 24 and 40 by is 8. So now that we have an idea of what is a greatest common factor, we're going to take a few examples here in practice. Okay, so find the greatest common factor. It's also commonly called the GCF, so just a shorthand way of saying it, GCF, for the list of numbers. Okay, so we can do a similar strategy what we did before, is we can list each factor for each of these numbers. So the factors of 20 would be 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5, and that's all we have. Okay. So let's look at the factors of 25. We have 1 and 25 and 5 and 5. Okay, so the greatest common factor, the biggest number that these two things have in common, that these lists that we made here, are 5. So the GCF is 5. So let's look at the second example. So the list here is 7, 21, and 28. So 7, the only factors of 7 are 1 and 7. All right, so does 7 go into 21? Yeah, 7 goes into 21. Okay, it goes into it 3 times. Does 7 go into 28? Yeah, 7 goes into 28 4 times. Okay, so 7 goes into 7 once, it goes into 21 3 times, and 28 4 times. Okay, so that means the greatest common factor, the GCF, is 7. All right, let's look at this next list of numbers here. So we have 5, 10, and 12. So the factors of 5 would be 1 and 5. The factors of 10 are 1, 10, 2, and 5. And the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, so the biggest number that 5 and 10 have in common is 5. We don't see 5 over here. Okay, 2 and 12, or 10 and 12 have 2 in common, but no 2 here. So the greatest common factor of 5, 10, and 12 is actually just 1. Okay, so we had some practice doing that. Now let's find greatest common factors for terms with variables. So the idea is really going to be the same here. So the GCF for 30x cubed y and 20x to the fourth y to the fifth, well, first of all, let's look at the greatest common factor of just 30 and just 20. Okay, so we can kind of think about the different factors. Okay, right away with numbers like this, I think to myself, okay, I know 10 definitely goes into both of these, but is there a bigger number than 10? No, actually, since 10 is half of 20, we can't have a greatest common factor bigger than that. So 10 is the start of it, but then let's also look at the variables here. Okay, so we look at the x first. Let's take a look at the x first. So we have x cubed over here and x to the fourth over there. So x cubed really means multiplying x by itself 3 times, and x to the fourth means multiplying x by itself 4 times. So we have 3 x's on the left, 4 x's on the right. So we both have at least 3 x's in each of those terms. Okay, so we would have x cubed. All right, and then if we have 1y over here and 5 y's over there, we have at least 1 y in each, so it's just y. So the greatest common factor for exponents on a variable is always going to be the smallest exponent on each variable. So we notice that between these two things, x cubed was the smallest, so we have x cubed and x to the fourth, so we had the x cubed here, and then just a y by itself over here, and y to the fifth over there, so y by itself is the smallest, so we have y there. So we're always taking the exponent, or the variable that has the smallest exponent on it, and that's going to be a part of our GCF. All right, so let's take a look at some examples where we have variables within our terms. So if we're finding the greatest common factor of 8x cubed and 24x, let's just start with that whole number out in front. So we should first look to see if 8 goes into 24 evenly, and it actually does. So 8 goes into itself once, and it goes into 24 3 times. So 8 is actually the greatest common factor here. And then let's take a look at the variables. Again, we're just taking the smallest variable. So in this case, it would just be x, because we have an x cubed and an x, so just x by itself is the smallest. All right, let's take a look at this second example here. So 25, 30, and 5. Okay, so when I look at those, I notice that 5 goes into each of those things evenly. So 5 goes into 25 5 times, it goes into 30 6 times, and it goes into 15 3 times. Okay, so if that's not immediately obvious to you, I would recommend just writing out the factors of each of those numbers there. And then, so that means the greatest common factor is 5. Okay, and then let's take a look at the variables. So we have w cubed, w to the fourth, and w squared. So w squared is the smallest, so that's a part of our GCF. All right, and let's take a look at the third example. We have negative m to the fourth, p to the fifth, and m cubed, p to the seventh. So again, smallest variable here. Okay, so m cubed, or smallest exponent in the variable. So m cubed is the smallest exponent, and then p to the fifth is the smallest p. And I also want to point out that we have that negative m to the fourth, p to the fifth. So because we have that negative 1 attached there, this greatest common factor could really be negative or positive. Okay, so I just want to note m cubed p to the fifth, our GCF, could be positive or negative. Okay, so I'm just going to write a negative sign in blue to show that it could be that as well. So now we're going to be given an expression. We're going to ask to factor out the greatest common factor. So in this first example, we're given the greatest common factor of 20x and 35 is 5. So what does it mean to factor that out? Okay, it means we're going to basically, what's going to go inside the parentheses is each of these terms divided by 5. Okay, that's what's going to go here, and that's what's going to go here. All right, so 20x divided by 5 is 4x, and 35 divided by 5 is 7. So how do you determine what goes inside the parentheses? Okay, divide each term by the GCF, by the greatest common factor. All right, so complete the factoring. So in each of these examples, we're given the greatest common factor, and we just have to include what's inside those parentheses. Okay, so we're going to divide each term by the greatest common factor. So this divided by 4x squared, and that divided by 4x squared. So start with the first one, 24x to the fifth divided by 4x squared. So we'll start with the numbers. 24 divided by 4 is 6. And then how many more x's do we have here in the numerator than the denominator? We have 3 more. Okay, so it's going to be x cubed. Okay, and then we have negative 28x squared divided by 4x squared. Okay, so it looks like those x squareds are going to cancel out right away. And then we're just left with negative 28 divided by 4, and that's going to give us negative 7. Okay, let's move on to the second example. Same idea. We're already given the greatest common factor here is 5x. So we're going to divide each term by 5x. Okay, 10 divided by 5 is 2, and x squared divided by x is just x. Okay, 25 divided by 5 is positive 5, and x cubed divided by x is x squared. Then finally, we have 15x divided by 5x. Okay, those x's are going to cancel, and we're just left with 3. So let's talk about a way that we can check our answers. So we've done the factoring. Okay, now we have to make sure that's right. So how do you check if you factor the problem correctly? Well, we can kind of use a few steps here. It says look inside the parentheses and make sure that the terms only have the number 1 in common as a factor. Okay, so if that's the case, that means we've successfully factored out the greatest common factor. All right, and it says use the distributive property to multiply the problem back together. So which is the correct factored form of 8x cubed plus 16x squared? Well, let's take a look at this. Okay, the first says the first thing in that little box to the right says the numbers inside the parentheses are only going to have 1 in common. We can see right here that we have an x squared in common there. And this one we have a 2 in common. Here we have an x in common. We have an x here and an x there. But we can see up here that x and 2 don't have anything in common. So the correct factored form is 8x squared plus, or 8x squared times x plus 2. And that's because it has the GCF taken out of the binomial. So the last part of the notes here, we just have 3 examples, and we're going to factor out the greatest common factor. So between w, so we have w squared minus 10w. All right, the greatest common factor for that is just going to be w. And then if we divide each term by w squared divided by w is w, and negative 10w divided by w is just negative 10. All right, and then to check this, again, if you look in that box above, you can still see it on screen. Number 2, it says use the distributive property. So if we just distribute that, w times w is w squared, and w times negative 10 is negative 10w, okay? And that checks out because that's exactly what we had over here. All right, now let's look at the second example. So we have 24t cubed plus 20t minus 36. So notice that minus 36 doesn't have a variable attached to it, so our greatest common factor isn't going to have a variable in it either, right? Because each term would have to have a variable for that to be included in our greatest common factor. So now we're just looking for the largest number that divides 24, 20, and 36, all right? And that is going to be 4, okay? And then if we divide each of these by 4, we're going to get 6t cubed plus 5t minus 9. And to check that, once again, we'd use the distributive property. So 4t cubed, or 4 times 6t cubed is 24t cubed. 4 times 5t is 20t. And finally, 4 times negative 9 is negative 36, which was our original trinomial, so we're good. All right, let's take a look at this last one. So it's nice when we have a prime number like 7 a part of our trinomial, because the only factors of that are 1 and 7. So we should ask ourselves, is 14 divisible by 7? Yes, it is. And is 21 divisible by 7? Yes. So our greatest common factor is 7, and then the smallest exponent, this is the variable with the smallest exponent, that's going to be this guy right here. So it's just x. So now we take each term and divide it by 7x. Well, 14 divided by 7 is 2, and then x cubed divided by x is just x squared. Okay, 21x divided by 7x, the x's are going to cancel, we're just left with 3. And then finally, we have negative 7x to the fourth divided by 7x. So the 7's are going to cancel, so we have negative, and then x cubed. Okay, we have 3 more x's on top. All right, and to check this, once again, we're going to use the distributive property. So 7x times 2x squared is 14x cubed, plus 7x times 3 is 21x, and then 7x times negative x cubed is negative 7x to the fourth. All right, and that checks out.